page 7 of normal distribution. So now we're getting into the part that is the most difficult. Even though it's the most difficult part, everybody in the class should be capable of doing these problems perfectly as long as you practice them enough, because there's a procedure, okay? There's two important things to the procedure. Number one, this formula, which is written in the formula booklet, so there's no reason to get it wrong, right? Notice that this formula is parallel to the formula that we already know from the transformations unit. The transformations unit has the x variable, the y variable. In the normal distribution world, we have the x variable and the z variable. The z variable is the x variable after it undergoes the transformation. The y variable is the x variable after it undergoes the transformation. The horizontal translation is c, or mu, and the horizontal compression or expansion is b, or sigma. Okay, in the case of b, it's a compression because it's in the numerator. In the case of sigma, it's in the denominator, so it's an expansion. Okay, remember, when the sigma gets bigger, the whole normal distribution gets bigger, right? Okay, so how are we going to use this formula? Let's take a look. 5a, find the mean and the standard deviation of a normally distributed random variable x, given that the probability that x is greater than 80 is 0.1, and the probability that x is less than 30 is 0.15. So first thing we're going to do is we're going to draw what this looks like for the variable x on the x standard, or the x normal distribution, not the standard normal distribution, the x distribution. Why isn't it the standard normal distribution? Because the mean is not 0 and the standard deviation is not 1. Okay, so it says that the probability that x is greater than 80 is 0.1, so that would be just like, 10% or 0.1 would be about that much, right? And this is 80, right? The probability is 0.1 that it is greater than 80, and that's exactly what I drew here. Now I'm going to draw this one. The probability it's less than 30 is about 0.15. So I'm going to draw a little bit bigger area. I'm going to call this 0.15, and this point here is going to be 30. So probability that it's less than 30 is 0.15. Do you see I just drew these two conditions on my x diagram? Okay. Remember, 30 and 80 are x values. 0.15 and 0.10 are probabilities. Now they want to know what are the mean and standard deviations for this distribution here. And notice, normally that's the first thing they give us. They give us the mean and the standard deviation. They didn't give us either. It turns out that since we have two little regions defined here completely, we know the x variable and we know the percentage for each one, it's possible to actually figure out mean and standard deviation. We're going to do that through this formula eventually. Okay, first thing we're going to do is we're going to draw this same picture in the z domain. So we're going to go down here and we're going to put the same shaded areas. And so this one is going to be 0.10, and this one's going to be 0.15. And we know that since this is the z-domain has a mean of 0, and it's got standard deviation values of adding 1 and subtracting 1, so it would be -1 and 1, etc. Okay, so now for the z-domain, we are able to find this value here by using the calculator, because we know this distribution completely. We know the mean, it's 0. We know the standard deviation, it's 1. We know these percentages, which means we can either use norm CDF or inverse norm and figure out the z values that are missing. Now remember, when we're going from percentages to the z values or the x values, we use inverse norm. So we're going to do second distribution inverse norm. And we're going to type in 0.15, and we're going to do a left region, so we just type 0.15 in directly. And mean is 0 and standard deviation is 1. They already put that in there. Perfect. And we find out that it's -0.10364. So I'm going to put that right here. -1.0 negative 1.0364. And then I'm going to do the same thing over here. For this one, I'm going to put 0.10 on the right side. So if it was the new calculator, I would put 0.10 in right. For the old calculator, I need to convert 0.10 into 1 minus 1.0, which is 0.9, right? So I'm going to do second distribution, inverse norm, and I'm going to put 0.9, and then I'm going to put 0.1 for mean and standard deviation for the standard normal distribution, the z domain. And I'm going to get 1.2816. So I'm going to put that here, 1.2816. Okay, and so now look at this. I have the z domain number, which corresponds to this x domain number. And I have this z domain number, which corresponds to this x domain number, which means I can write down an equation based on this formula. So let's do that. So I'm going to write down a transformation formula based on z equals x minus mu divided by sigma based on these numbers. So I'm going to put z value of negative 1.036, right? Equals, and then I'm going to put x, which is 30, and then I'm going to leave mu and sigma blank because I don't know those yet. Then I'm going to do the same thing for this pair here. For this pair here, z is 1.2816, x is 80, and mu and sigma we don't know yet. All right, now we have two equations and two unknowns. So now we just need to do a little bit of 8th grade algebra in order to find what mu and sigma are. And in order to make this easy for ourselves, let's use the calculator. To use the calculator, what we'd like to do is we'd like to put it in the form blah, blah, blah mu plus blah, blah, blah sigma equals blah, blah, blah. If we do that for two different equations with mu and sigma in them, notice that we can solve these using elimination or substitution with algebra, or we can use the calculator PolySMLT command. So let's see how we do that. First thing is we need to get sigma out of the denominator. So we're going to multiply both sides by sigma. Negative 1.0364 sigma equals 30 minus mu. Now we're almost done. Add mu to both sides. Mu minus 1.0364 sigma equals 30. How many mu's? 1 mu, right? So now we already have an equation which is in this form. Let's do the same thing for the other one. In the other one, we're going to multiply both sides by sigma, so we'll get 1.2816 sigma equals 80 minus mu. And then we'll add mu to both sides. Mu plus 1.2816 sigma equals 80. If we want to, we could put a 1 there. Now we have another equation. And so now we have two equations. They're both in this form here. So let's type them into the calculator. So for this calculator, we're going to go into apps. And I have PolySMLT, so I'll go to number 2 where it says PolySMLT. And then I'll hit enter again. And then I'll go to simultaneous equation solver. And then I'm going to put 2 and 2. And then I'm going to type in the coefficients. So I'm going to rewrite these in this form so it's really easy to see what I'm going to do. I'm going to put 1 mu minus 1.0364 sigma equals 30. And then the other side, I'm going to put 1 mu and 1.2816 sigma. 1 mu and, 1.286 sigma equals 30. Is it plus? Oh, it's plus, okay. And now I'm going to type this into the calculator, but I only need the coefficients. So I'm going to underline all the coefficients that I need. And, and this one was 80, sorry. Miscopied. This will be 80. Okay. Let's type those in the calculator, shall we? So the first one is 1. Both of the first ones are 1. And then the second one is negative 1.0364. And the other one is positive 1.286, and then the other ones are 30 and 80. And then I press solve. And it gives me the answer in fractions, but if I press this button here, FD, it changes it to decimal. So 52.3, mu is 52.3, and I know it's mu because it's the first one, and sigma is 21.5. Does that look reasonable? I go back to the x domain. If I put 52.3 here, does that look reasonable? Yeah, it's like halfway in between the two. That looks about right. Okay, so that was solving the first part, the mean and the standard deviation. Part B, now we're done with the hard part, by the way. Part B, in a mathematics examination, it was found that 10% of students scored at least 80 and no more than 15% scored under 30. No more than 15% scored under 30. So that means 15% scored under 30. Assuming the scores are normally distributed, what proportion of students scored more than 50? Okay, so in this case, what they want is, they want to know, in this distribution here, with a mean of 52.3 and a sigma of 21.5, what is this green region here that is above 50, right? So how do we do that? This is an easy problem, right? It's not a hard problem at all. What we're going to do here now is we're just going to do a normal second distribution norm CDF problem. Now we know, that the lower is 50 and the upper is infinity. So I put 50 and infinity, which is 1 EE99. And then I put 52.3 for my mean. And I put the standard deviation, which I found, which is 21.5. And paste twice. 0.543. So the answer to the second one is 0.543. That looks about right, slightly more than 50%, right? Okay? So part A was the hard part. Part B was the easy part. Okay, now let's do one more problem like this. The heights of 13-year-old boys are normally distributed. 72% of them are above 131. So let's draw that first. 97% of them are above 131. So that's like almost everybody, right? 97% of them are above 131. And 2.28% are above 179. Find mu and sigma for this height distribution. Okay, so this is basically the same type of problem. Notice that instead of giving us a left side region here and a right side region here, they gave us two right side regions. Okay, but no big deal. All right, so now we make another distribution. This one is the x distribution, and this was the z distribution. We need to draw the z distribution for this because we don't know the mu and the sigma. They're asking us for the mu and the sigma. So let's make a similar drawing for the z distribution. And for this one, I have 0.0228 here. And for this region here, I have, let's see, 0.9773 minus 1. Which is, it's 0.0227 on the left side. 0.0227 on the left side and 0.0228 on the right side. So they're almost the same, aren't they? Okay, and let's see. So we're going to figure out for the z distribution, we know that the middle is 0, and the standard deviation values are 1. We want to find out this value and this value in terms of z. So let's figure that out. How do we do that? Once again, we're going to use the calculator second distribution inverse norm. For the left interval, we're going to put 0.0227. And mu and 0 are 0 and 1, of course. So we get negative 2.0009. Okay, and I'm keeping this. You remember how I said that sometimes you're going to want to keep like a whole bunch of sig figs, like 5 sig figs? That's why we're doing this. That's why we're keeping 5 sig figs for this one. Okay, and then we're going to do the same thing for the other side. So now we're going to do, again, second distribution inverse norm. And this time we're going to put the right side area for 0.0228. So that's going to be 0.9772. Is that right? Let's put 1 minus 0.0228. We're going to put the left side region instead of the right side region because the old calculator only understands left side regions. And it's going to be 1.9991. Okay, so now we have our z values, and so now we can make our two equations, z equals x minus mu divided by sigma, based on this pair of x and z's. So we're going to put negative 2.0009 equals 131 minus mu divided by sigma. And we can rearrange it a little bit so that it's all calculator ready by putting sigma on top and then adding mu to both sides. Mu minus 2.0009 sigma equals 131. Okay, so we have one equation that's all ready for the calculator. Let's do the other side. So the other side, we're going to have x and z. So our z value is 1.9991 equals 179. 179 minus mu divided by sigma. And so I'll rearrange it a little bit. Okay, and then I'm going to put the mu on the other side. So 1 mu plus 1.9991 sigma equals 179. Now I can put these into the calculator. 2.009, 1.9991, 131, and 179. And then we can solve for mu and sigma. Let's do that real quick. APPS, PolySMLT, simultaneous equation solver, which is number 2. And then 2 next. And we're going to put in 1, 1, and then the next column we're going to put negative 2.0009 up 2.009 negative 2.0009. Oh, it took it fine. I saw the 1 there and I got confused. 1, and the next one's going to be 1.9991. And then the coefficients are going to be 131 and 79. 131 and 179. Solve. So the mean value is going to be 155.01. So 155. And the sigma value is exactly 12. So I'm going to write that down here. 155. And then this sigma value is 12. Does that look about right? Yeah. 131, 179. 131 to 155 is about 24. And then 155 to 179, that's also about 24. So, yeah. Looks good. Finally, it says, a 13-year-old boy is randomly chosen. What is the probability that his height lies between 143 and 191? So let's take a look at that. 143, let's say it's about here. And 191, let's say it's about here. So what is the probability that the boy's height is between 143 and 191? How do we figure that out? That's an easy kind of problem. We just do norm CDF, right? So distribution, norm CDF, and we put 143 and 191 for our limits. $143 and $191, and our mean is $155. And our standard deviation is 12. And the answer is 0.839999, also known as 0.840. Okay, so the answer to this is 0.840.